inaugural invited speaker series for the Center for Research on Complex Thinking. We are delighted and honored to have Golnaz Arastoopour as our first speaker. Gol was actually a graduate student here a while ago. She graduated from Northwestern for a postdoc and then took a faculty position in Clemson and has just recently moved to Vanderbilt, which is fabulous. She was my student, and it was an amazing student when she was here and has done her more amazing work since. And I'm delighted that she's been here to tell you not necessarily about everything that she's doing, but about something that's actually fresh. Hopefully that will make a sort of engaging and timely talk. So please welcome Golnaz Arastoopour.
Let's see, mic on, recording on. Okay, we're good. All right, thank you, everyone. Thank you to everyone for who is organizing this talk series and for inviting me to come share some of my work. As David mentioned, I did graduate at some point from this university, working with David as my advisor. It's been an interesting journey since then. Right now I'm at Vanderbilt University. I want to say that I'm part of this LIVE initiative. It's the Learning Innovation Incubator. It's a new initiative that brings faculty and staff from across the university. It's transdisciplinary and it's a really exciting place to be. That's one of the reasons I'm at Vanderbilt University now, and it's run by Dr. Alyssa Wise. And I'm also the director of my own research lab called the Idea Lab, Inclusive Digital Education and Analytics. And they gave me a really nice title when I came to Vanderbilt. I'm assistant professor of human-centered learning technologies, which is exciting. So that's the direction my work has gone in. And today I'm going to talk just a little bit about two studies. I'll try to go in as depth as I can to tell you about some of the work we've been doing around developing sociocritical AI literacies in children. So just in a nutshell, my work is really about generally finding just important, interesting, complicated issues and ideas that adults are dealing with. And then I'm trying to figure out how to build developmentally appropriate tools so that children can have learning experiences and to engage with these complex ideas, which is not easy to do, but I welcome the challenge. So first off, these are all the amazing graduate students, postdocs, staff members that I have across Clemson, across Vanderbilt now, who without them, none of this work would have been even close to being possible. So they are a big part of what I do. And I have so much love for my graduate students. So I wanted to thank them first. And then the other thing I'll say is, I'll just mention this really briefly, but this work is really important to me. And let's see if I can say this without getting too emotional, but on Friday, the NSF career grant that supports this work was terminated. And so one of the things I wanted to share today was especially about all the relational and important equity-related work that I'm doing with children, both in South Carolina and in Tennessee. And so I restructured my talk a little bit to focus a lot on some of those things that were really important to me that are now being terminated in our country. So I'm talking a little bit about AI, developing AI literacies for young children. And AI is everywhere, we know this. And this is a screenshot from Google claiming that, talking about AI for social good. So AI has been, in the media, and what does it mean? It has a lot to do with machine learning or deep learning. There's lots of ways to think about AI. And companies are talking about using AI to solve a lot of the world's problems. But on the flip side, there's this issue with AI. So one of these, this headline kind of calls to attention some of the issues we've seen. Google's image search has a massive celebrity sexism problem. Search for a male actor and Google's image suggestions will point you towards their filmography. But when it comes to female actors, Google is more interested in showing you their bodies. So we're seeing this flip side to AI. Although it's improving our quality of life in a lot of ways, it's also harming certain populations. So one of the people who has been really digging into this work for the last decade or so is Safiya Noble. She wrote this book called Algorithms of Oppression. And what inspired her was she Googled the term Black girls to find activities for her daughters and nieces. And instead of finding these positive representations, she was met with these negative stereotypes towards Black girls and women. And these searches use AI for their autocomplete, and they have a lot of algorithms on the back end that people who work at Google program. When she searched for white girls, she didn't get those results. And so this was really striking to me. What's happening here is algorithmic bias. As she explains, these are data sets that are used to train AI models that may exclude certain populations or represent them in negative ways. This is only part of the problem, because simply adjusting those data sets or mitigating bias in those data sets doesn't solve the problem of harm. So as Ruha Benjamin has recently been arguing, there are broader sociopolitical systems at play when we design and use technologies, and especially in this era of AI and deep learning. So there's lots of examples here, but really quickly, one example is with the justice system. So AI predictive policing relies on data sets that may not actually include an individual's race, but it includes variables such as crime rate, geography, neighborhood, other sort of historical variables that are correlated to race and result in racial disparities in predictions. So Ruha Benjamin argues that such models encode racism and other forms of discrimination because they're built from data and using so-called naturally occurring data in society that are historically discriminatory. So she argues that racism is not always explicit and intentional. It can be embedded in the technology and data that we use. So this is one of those big ideas that I want to figure out how to engage children in. So children are avid users of digital technology and now AI at very young ages. If you don't recognize, this is my son when he was, I was two years old maybe. So my work recently has been thinking about, well, what do they need to know about big data? And what do they need to know about AI and machine learning? So right now, there's still no agreed upon K-12 AI and machine learning standards or competencies. We've seen examples emerge from the literature from Long and McGarrico. That's a pretty famous one. Turetsky and colleagues, they do AI for K-12. And just the other day, I received an email from Teach AI, which is a group of policymakers, researchers, collaborators. They're holding a draft AI literacy framework launch on May 22nd. So this work is really new. It's still ongoing for K-12. There's also been designed learning activities from MIT Rays around K-12 ethics and AI. So examples come from Williams and colleagues. Morales Navarro and colleagues are doing a lot of work where it comes to designing these developmentally appropriate tools to engage K-12 students in learning about machine learning and AI. But the ethical and humanistic orientations are not fully integrated throughout these proposed competencies, nor the tools and learning activities. Saper Vakil has been doing some of this work talking about integrating ethics in computer science, and he argues that ethics explorations in computer science education tend to focus on a microethics, which are centered on individuals making decisions when faced dilemmas. So if you think about kind of traditional ethical dilemmas that are posed to you, what would you do if you were in this situation? We don't see a lot of the broader sociopolitical context being integrated into STEM classrooms, not in computer science, and for sure not for K-12. Even elementary and middle school, people are not really thinking about doing that. A lot of times ethics comes at the end, or it's kind of an add-on. So what I'm arguing is that deep participation in debates around societal, ethical, and political impacts of AI requires a foundational technical understanding of AI. So what that means is, if you actually want to participate in these societal and ethical issues and discussions, you have to actually understand how the AI works at a fundamental level. Otherwise, you can't engage deeply with these ethical issues. On the other hand, developing a technical understanding of AI also requires a foundational understanding of the societal, ethical, and political system. So what I'm arguing is that these things need to be integrated, and they are not currently in a lot of our learning systems and educational systems. Even beyond education, they're not being integrated. But on this right side, if you are developing a technical understanding of AI and you're building these AI apps for people to use in society, you have to understand how society works. And so I'm arguing for the integration of this. Okay, so what's so special about AI here? Why am I focusing on AI? I mean, one reason is everybody's talking about AI and it's here, but what is so special about AI for learning? So one of the things I'm playing around with arguing is that AI, because of its ability to output human-like products now more than ever, if you talk to ChatGPT, right, you're getting human-like responses. And these are based on large amounts of data from people. AI applications are essentially acting as a mirror. They're reflecting simulations of our problematic histories of oppression and exclusion right back at us. So this is different than technology we've seen in the past. We're seeing more human-like generated responses that are based on this data that we have in society, as Ruha Benjamin was talking about. So for children, such experiences with this interactive mirror are especially negative for them, who are at vulnerable developmental stages in their lives. So if they're interacting with these tools now, right? And they're seeing this sort of reflection, it can be especially harmful. AI also acts as a microphone. So it amplifies AI amplifies systems of oppression by automatically classifying and making decisions at large scales based on problematic histories. More and more often now we're letting AI make the decisions, sometimes with humans in the loop, sometimes not. And these are happening at larger scales than we've ever seen before. So when AI is trained on data with a small amount of human bias, recent research has shown that the algorithm may exploit and amplify these biases as the algorithm interacts with humans. And even more concerning, in a recent study that was published just last year, as humans interact with these algorithms, research has shown that people can begin to internalize these same biases themselves via a human AI feedback loop. So I know that sounds all scary, but I'm going to pivot now. These technical abilities that actually make systemic oppression louder and more visible can also serve as a powerful opportunity for children to learn by critically reflecting and reimagining the world around them in constructed, designed, safe environments for children. So AI can be a powerful opportunity for children to learn by critically reflecting and reimagining the world. If learners are provided with developmentally appropriate computational tools, as I'll show you in a little bit, that can guide them through some of the functional aspects of AI, they can explore and develop applications that serve as a foundation for critical societal interrogations. They can use, modify, and create technologies and explore which cultures are being amplified and which are being silenced. So I've been thinking about this a lot the last few years and putting together this framework. And I'm thinking about how learning theory, right, how we can ground some of these ideas in learning theory. So I'm thinking about this framework here that I'm developing and how to integrate the sociopolitical and the technical when it comes to computational learning and in particular AI learning for children. So this is grounded in sociocultural learning theory that argues that learning is social and situated, and tools like language, symbols, other computational tools facilitate our learning. So learners interact with and appropriate tools or change them in ways that matter to them. And then I'm also borrowing a key idea from constructionist principles right here in the center, that computational tools are objects to learn or think with. And this is the tinkering feedback loop that you see in the middle. That's the central mechanism for learning in this framework. And again, it can be other computational objects, but thinking about AI, right, really highlights this tinkering feedback loop as the learner interacts with these AI tools and can kind of crack them open to see what sort of data, for example, are being trained or being used to train the AI algorithms. That kind of mirror reflective property becomes really important in that tinkering feedback loop. And so this framework helps us think about, well, what are the ways that tinkering with these AI objects, whether they're already designed or children are designing them, how can it help them question, reimagine, and rebuild AI with the social justice lens, thereby developing their sociocritical AI literacies? All right, so I'll show you some data now. So the first study I just want to show you, it's a quantitative ethnography study, called study number 1. It uses ENA on some of the data we collected. I worked with 2 nonprofit community centers with after-school programs. So after-school programs was a good place to start with this sort of experimental design. And I don't mean that in the statistical way. This was just very highly experimental, the kinds of things that we were asking children to do that really nobody has asked children to do or think about before. And so this was right in the middle of COVID, 2020 to 2021. We had 50 total children going in and out of the after-school systems over 2 years, 3 researchers, 2 staff. You can see the ages upper elementary to middle school. And I won't go into the details of this, but just know that my work is very relational. So before we actually do any research, there's months and months of relationship building with these children in the after-school centers and with the staff. And my design work can be for a different talk. Okay, so we collected student artifacts, reflections, interviews, observational videos, notes, and reflection memos. I can talk more about the methods if people want to know more about that. But here's the kind of key part. We used Google Teachable Machine. Now, if you're not familiar with Google Teachable Machine, it's an interface to create your own image or pose classification models. And so you use your webcam, you feed it image data, and you tell it what classes you want it to create. And these are some of the examples here. So this example, for example, this example tells you whether something is a marshmallow or not a marshmallow. Now, the Google Teachable Machine will just help you create this classification model, but you can hook it up to physical computing like this example shows. And so once you train the model to recognize whether something is a marshmallow or not a marshmallow, this person has developed this physical system that'll then sort it. And the interface is okay working with children as is out of the box. So here we had a lot of activities that we've designed, and I've gone through lots of cycles of design-based research. And again, I won't go into the details of the design work, but here are the activities that we have for this critical machine learning program that is available online publicly too. So I'm going to just talk about a few of these items so you can see what kids were actually doing and what I'm going to say about what they were doing. So we had a pre-post drawing task. So instead of giving them a survey or a question or something, we gave them space to kind of draw their conceptualizations of what is a computer algorithm and what is machine learning. Now I'm just showing you this so you can see from the beginning to the end of the program sort of a little bit about what sort of changes we saw. This is the majority of what we saw in the pre. Not surprisingly, right? Algorithms, what are those? Machine learning, haven't heard of it yet. So this is the majority of what we saw. By the post, this was the majority of what we saw. And so an algorithm, they were drawing, they had some writing as well, but you can see they recognize the Google Teachable Machine is a computer algorithm. And so on the left, they have the classifications of flower and tree, and then they have sort of what you saw with the marshmallow, not marshmallow, the flower and tree on the left. And then the machine learning, she has a similar thing. So she talks about whether the machine can recognize that there's a face or not a face. So they're starting to, remember, these are 9, 10-year-olds. They're starting to sort of conceptualize, okay, now I know a little bit about what a machine learning algorithm is. All right, so let's talk about what they were actually doing. I'm just going to show you one activity briefly. This is adapted from MIT Raise. They have a bunch of AI activities. We borrow some of them, adapt some of them, and adjust it so that we're focused more on the ethical and the sociopolitical. So the first thing was this cat-dog activity. So the narrative here was you're designing a security system for cats and dogs at your door, and it uses facial recognition. So there's a facial recognition algorithm, and you want to train it to recognize a cat and a dog. So we gave them training sets and test sets, and we explained, what those were. We had discussions about them. I think it's pretty cool that an 8-year-old can tell the difference between a training and a test set, right? We explained that, if you use the same data, for example, for the test set, that's like cheating on a test. And that was something that one of the kids thought up of themselves. So in the training set, we have dogs, we have cats. They have to, play around with Google Teachable Machine to tinker with it and figure out how to do their different classes. And then they have a test set. So the test set, of course, is different than the training set, and they have to hold it up to the camera on Google Teachable Machine and see if the model actually recognizes this as a cat. Now, the model does really well on cats, but it doesn't do so well on dogs. So it misclassifies dogs purposefully. This is a purposefully biased training data set that they discover. And so you can kind of tell that dog is borderline, right? Which is why the machine, right, was not be able to classify it properly. It didn't have enough, right, images of dogs. It didn't have a diverse enough set of images of dogs. It didn't have variety. It didn't have enough. Those were the things we wanted kids to discover as they were tinkering with this tool. So we had discussions, they could write, there was lots of different kind of pedagogical techniques that you would see in a classroom. But the question was, who did the machine work for and why? So we had 18 children who have submitted this activity fully, and 17 out of the 18 said one or more of the following. Well, because there were more cat pictures, more kinds of cats, better pictures of cats. So they were able to kind of look through that. We made the training and test set visible to them so they could actually explore and see why this was happening. And some of them said, well, the dogs were different in the test set than in the training set. So sort of in their own kid language, saying that there weren't enough variety of dogs. So this is what the written portion of that looked like. What did your machine? It's really simple because there are more pictures of cats and more kinds of cats. Now you might be asking, well, what did that one child say? You said 17 out of 18. What did that one child say? Something that we didn't expect. But still true. You said because my hand was shaking. That's why it didn't work. That's why it was working really well on one. So not what we were looking for, but also thinking about human error, right? So some of the things the students would bring up would be this, or the lighting, or, I was close or I was far away, things like that. And of course, they love classifying themselves as whether they're cats and dogs. It could be a whole paper. And then the last activity I want to talk about is the robot superheroes and the build your own machine learning for social good. So there are these scaffolded activities, right? Like we're going to give you, you're going to discover sort of what a bias training data set looks like. And now you're going to build your own machine learning model. And not only that, you're going to have your machine learning model, you're going to have a robot, program a robot to respond to those classifications. Because something we learned in the first iteration of this was just creating a model for kids that young is not enough. They don't care that it's a marshmallow or not a marshmallow. They want it to be sorted. And so they want the machine to recognize something, and then they want to see that realization in the real world through physical computing. So this is what the after-school space looked like, just so you can kind of imagine, right? You have these little robots. They're using block-based programming on their screens. This is Scratch. We use Scratch API. We've adapted it for our purposes. And then their blocks are, they're building their models. So you can see they're using their camera and they're moving around a lot. So this is what the space looks like. So this is what I meant by sort of experimental, right? They're free to roam around. There's some adults wandering around helping them. They're playing around with these robots. They're testing them and seeing how they're working. And it looks like they're having fun, I think, anecdotally. So one example of the superhero robot was we wanted them to create sort of this story. It could be any sort of visual story. And this is one example of that particular group of girls, actually. They had the servant robot, Ted. They said, this is Ted, the servant robot. He's the size of a human. You say, hey, Ted, you turn him on, and so on. So Ted, if you can imagine, just does everything. So it's like this robot that'll clean your room and do your homework and all kinds of things. So this was by design. We let the kids go wild with their imaginations. And then the adult role was to help them narrow it down so they could actually build a prototype using the technology we had, which you see is a robot that can do some limited things and then an image classification model. So there was also some voice classification that they can use as well. So this is actually part of their code and what it looked like. You can read more about this in some of the publications I have. Okay, so analyzing the data. We used QE, so some people in this room are familiar with QE and ENA, but what happened is every time that a student did something, so if they submitted that worksheet, right, that was a form of utterance of discourse, or every time they said something in a discussion. So we put these in lines in a spreadsheet, and then we coded ones or zeros for these different codes. Now the codes were grounded, meaning they came from what we were seeing in the data, what we were experiencing, because there's no framework for this quite yet. We borrowed a little bit from the AI literacies framework, but here are the kinds of things that we were seeing. How people develop machine learning apps, the harmful applications of them, and the helpful applications of them. And here are the details of those codes. So talking about whether algorithms have limitations, how they're made by people. So thinking about there's actually people who are encoding maybe their opinions or their biases into the algorithm, and then understanding how machine learning classifications work, how training data bias, what that actually means, and then talking about the broader social issues of racial discrimination, gender discrimination, which we discussed in class. So building these network models, we looked line by line and looked at the co-occurrences of codes per line for each student. So for example, if there was a connection here between diverse users and the fact that algorithms have limitations, that link would be connected to something a student said, like people draw differently. This is in response to the Google Draw activity. People draw differently, like it might say mask, but you meant a face mask and you drew a Halloween mask. So talking about how this Google Draw algorithm couldn't guess what the person was drawing because of its limitations and maybe not thinking about a diverse set of users. That's an example of how these network models were made. So I'm not showing you the pre because there were no connections in the pre, mostly IDKs. There's just no network. There were a few scattered codes here and there. But again, we're looking at I'm using ENA because I'm looking at the connections between some of these ideas about technical ideas about machine learning and the sociopolitical. So you can see the connections that were made. One of the strongest connections were between how machine learning classifies algorithms and racial discrimination. So one of the videos we showed them, one of the things we talked about was racial discrimination in facial recognition systems. So one of the pieces of discourse from a student that contributes to this line is, in the video we watched, the girl realized that the computer didn't recognize her face until she put her white mask on. It wasn't fair because most of the pictures of faces were white men. So we had this discussion after they tinkered with that algorithmic bias. After they tinkered with Google Teachable Machine, then we talked about algorithmic bias and gave an example of Joy Bulamwini's work, which this student is reflecting on. And then there were, I built a network for each of these activities. So they're a little sparse, but we can see connections here. When they were doing the cat-dog teachable machine, they were talking a lot about the limitations of the algorithm, whether training data was biased because of the variety or maybe because of the number. So that's what you were seeing here. And then what I did was create a network for each of these activities. You can see pre is right in the middle because it was 0, and then post is a little bit to the left. But each of these activity students were focusing on different things. And we can see that using the networks, there is a significant difference between the pre and the post in terms, not surprisingly, because they didn't say anything in the pre, and made a lot of connections in the post. And so if you remember, some of the strongest connections here were between machine learning, how the classification algorithms work, connecting it to racial discrimination, and thinking about how the people behind the scenes are maybe not thinking about a diverse set of users. So the key learning findings from this study was that children described and discussed how marginalized populations may be unjustly excluded or harmed when biased data sets are used to train machine learning applications. And children were also able to reimagine and build machine learning robotic applications for social good to support marginalized populations, such as other children who are not being served by current technologies, sort of. So in these first cycles, these first iterations, the kids mostly leaned into the more playful and joyful aspects of designing their machine learning robots. Not surprisingly, right? They're upper elementary, middle school kids. They wanted, once they had the power and the agency to build their own models, they just wanted to do stuff that they cared about, do stuff that were important to children. So they focused more on their own interests. They focused more on helping children as their social good. And one of the outstanding questions still remained. How much of the discussions facilitated sociocritical AI literacy, and how much of it is the tinkering with the objects? And how much of it is tinkering with existing applications? And how much of it is building with their own models and robots? Maybe I'm anticipating your questions. So let's do one more study. So this is QE study number 2. This is ongoing. Literally, these girls are going to present their machine learning models and robots and zines. We did zines this time instead of a scientific poster in 2 weeks. So I'm really excited for that. But we were able to analyze this data and have submitted it for publication somewhere. So now I'm in Nashville, and in less than a year, was able to find this wonderful private middle school for girls of color. They're all African-American girls in this school. It's a small school, 16 students. Again, we're just doing this now. So one instructor, which was me, basically, for the first round, and 2 researchers, so ages 11 to 13. So this is a very different population. In South Carolina, we had mixed races, mixed gender identities. Here, they all shared one racial and gender identity, which was African-American girls. So it's also a school that promotes culturally responsive learning and discussions around race and equity. So this was a really unique opportunity to see how far we could go with some of the sociocritical understanding. So I'll share what we did here. This is one of the girls that we worked with. You can see we also upgraded our robots. They're much cuter now. So same sort of codes that we used again on same sort of data analysis too. I'm using QE, collecting the similar data, similar activities. But now we're digging deeper into the racial inequity with this group of children. And we're able to, because they have these lived experiences that are related, and the school and the space was a space that kind of discussion was welcoming. So I used those codes from what critical machine learning that you saw. The algorithms have limitations, but now I'm borrowing from Dr. Tier Tanksley's work, critical race technology theory. This is leaning into critical race theory, this idea that there is embedded, as you heard from Ruha Benjamin, embedded racism in some of these AI technologies. And so these are the things that we were looking for and were able to highlight in some of this data. Challenging dominant ideologies and technologies and expressing a commitment to social justice. And now we got smarter. Now we're thinking about how are we framing these activities? So again, in that experimental space, it was just kind of these activities. And I'm not talking too much about my design work, but we get a lot of feedback from the children. So I do participatory work with design with children so that we get their feedback and their engagement in the design of their learning activities. So the activity groupings here, now we have the staggered activity grouping. It's the same activities, but they're more intentionally grouped. So interact and critique, where students engaged and critiqued existing AI applications. And then we have critique and reimagine, where students critiqued AI technologies and envisioned socially just alternatives. And then we have reimagine and build. So students design machine learning robots aligned with socially beneficial goals. So this was the staggered design that we can now talk about. And then it gave us this framing then for the QE analysis. So now I have each dot represents one student within one of these categories of groupings. And now we're getting more evidence as to what's actually happening, that question I was asking, what's actually happening in these activities? Is it the discursive activities that are facilitating some kind of learning? Is it the building? Is it the tinkering? And this is going to tell us a little bit more about that. So in the interact and critique activities, where they were interacting with Google Quick Draw and Teachable Machine, the cat dog one is the same activity. They're interacting and critiquing. We saw sort of the same things that we saw from the last study. But up here in the critique and reimagine, those examples where we showed them existing examples of biased technologies were really emotionally charged for this group of girls. And they were really engaged in critiquing them and reimagining them. And you can see that's this ENA space here up there, the blue dots that are up there, those discussions were really focused on technological racism. And then when it came to reimagining and building, it was more still connected to technological racism, but more about humans designing and model functionality, which isn't surprising because they were building their models. So this is what the network looked like for the interact and critique. These things that say CML on them are from the first study, so critical machine learning. So again, acknowledging algorithmic limitations, defining classification algorithms, acknowledging bias, and then you see the technological racism has fewer connections to it. So we saw, again, similar things from study 1. Study 2 is where, this is where the action's happening, critique and reimagine, that I want to show you some examples from. So one of the activities we did was a Google search activity. This was inspired by Safiya Noble's work, where we search up different things. And we've done this activity, this is probably the 5th time I've done this activity and collected data on it. The first thing we explore is pizza. And we look at the different images of pizza that show up. Cheese pizza versus pepperoni pizza. Some people are like, well, I don't like pepperoni. Why am I only seeing pepperoni? And we talk about bias in terms of pizza. Then we shift to people. And that's where we have a more contentious, discussion. So we shift to people and we start to look for occupations. So one of the girls said, let's look for pilots. And then I said, well, what do you think is going to happen if we look for pilots? And they said kind of stereotypical stuff. I'm going to see someone in a pilot costume. She said costume. The rest said more descriptive things about airlines. I'm going to see Spirit Airlines. I'm going to see this. One girl said, I think we're going to see mostly white men. I said, okay. So we searched up pilot, and this was very unexpected. I expected to see mostly white men. We saw this, an AI-generated image of a black pilot, the only black pilot. And it said under there, and I was thrown off because one of the girls noticed, and I actually didn't notice. And so when the images were revealed, right, they noticed, yes, majority white men, but Kalani, one of the students, they also picked their own pseudonyms, so a lot of them rhyme, so bear with me. Kalani pointed out that there's one photo of a black man, and then Lori jumps up out of her seat, goes up there and says, it's a fake black man. It's a photo AI. That's what she said. She meant AI-generated photo. And the others, he's not real, right? Chaos ensued. I'm just caught like, oh, wow, this is a teachable moment. At some point in the discussion, so after, we discuss later on in the discussion, Mia says, it's because in the past, people didn't think that other races and other genders could do the same thing that white men do. So they're looked down upon. So now there's not as many as there should be. This is an important connection here. And this is after, other activities. I'm just kind of highlighting the things that were happening. So Mia is making this connection of historic systems of oppression related to the technology, right? She's thinking it's in the past. This is an ongoing thing where we've had racism for so long, and now we're seeing it embedded in the technology. This is, again, what Ruha Benjamin is arguing. Tia says, there's not much of me there. So there are no, I think there's maybe one black woman pilot. There just needs to be more of us. I think Google could put more images in this category. I think it should be some real pictures instead of some AI pictures. They, Google, should be more inclusive, even if it's not the case in the real world. So this is pretty radical thinking, right? This is saying, this is the kind of data that Google's using, but why do they have to use this kind of data? Why can't we reimagine, or do something differently where we actually have this imaginative space, right? Reimagining not just the technology, but where the data come from, the social histories of where the data come from, and so that I can be included. I thought this was pretty powerful. And then I'll show you one more example. This was very difficult to pick examples. You have to trust, you have to read the paper when it gets published. There's so many good examples here. One other example that I'm going to choose to share has to do with this robot. This is Moxie. Moxie is a socio-emotional robot designed for children. I showed them a video of Moxie talking to a child about lollipops. Dr. T.R. Tanksley, again, has published work on talking with a group of Black high schoolers about Moxie, and they experimented with Moxie. And one of the things they asked, when they asked Moxie about Black history, Moxie said, let's do something more fun that sounds like a sad topic. And so I brought that up to the girls, showed them those examples, explained who Dr. T.R. Tanksley was and what her work was, and that this was something they discovered. And I explained, these are high school students just like you who are looking at this robot. What do you think? Kiera, very emotionally charged. Black history is not only sad. I feel like they're only talking about slavery, but slavery is not the only thing. And Tia said, there's something sad about us? Kiera, no, not sad. Some good stuff happened too. Like he could have talked about that girl. And then she points to a photo of Mary Jackson, NASA's first Black female engineer. And she says he, meaning Moxie, they're personifying the robot, he could talk about live people and not like things that happen to us. This sentence is really important because she's talking about whose perspective is embedded in the technology, right? And she's separating herself, right, as a Black person, saying us, right? These are things that happen to us that somebody else's perception is negative, and it's embedded in this technology, and I can see it now. And then she's reimagining. She's saying, why aren't they talking about Mary Jackson? Why aren't they talking about the good things that we did, right? These historical Black figures in the US and more globally. Oh, and then I'm asking them questions such as, well, why do you think that is? Why? So I'm here asking probing questions. Why do you think this is? Can you say more about that? What do you think should happen? Those are the kind of questions that I'm asking. So Mia says, when I asked, well, why do you think that is? And she said, maybe it's that thing that you, pointing to the instructor, were talking about the other day, where it's like in your brain, you don't even know about it, but how it's like Black history as negative. So I'll translate this a little bit. She's talking about implicit bias, right? And implicit racism and sort of these ideas that are embedded in a lot of the things that we do that people who are designing technologies might not think deeply about, that what the effects of these can be on marginalized populations. And so she's saying maybe it's like in the designer's brain, this implicit bias that they don't even think that they're representing Black history as negative when they really are. I mean, that's how those girls were responding. This is not good. This doesn't represent our culture. This doesn't represent my history. And so the discussion continued on, and they reimagined more of what the robot could do. So they liked the idea of a socio-emotional robot companion. They weren't throwing that out the window. They said this could be good for kids. But if they would redesign it, obviously they would remove what that robot said about Black history being sad, and they would include more Black culture. And this is what we also saw with Dr. Tanksley's study. They redesigned the robot and reimagined what it could be without completely throwing away that, that this could be a good thing, could be a socio-emotional robot for children. All right, and then the last part, I'm going to share Kiera's machine learning robot and her classification model. So this is the ENA network that we're seeing here. Again, we saw it from the blue network, right? Fully connected network. When they looked at existing ML applications, we're able to tinker with them a little bit and discuss them. We see those connections being made. Here we see fewer connections. I mean, one, in all honesty, it was difficult to collect a lot of data when they're running around and doing that, but we're going to solve that problem in the future. But one thing that's happening here is there's a focus on how the machine learning classification models work, that they're made by humans like them, and thinking about that. And being able to define it. And we do see some connections to social justice and acknowledging technological racism. This was Kiera's image classification model. Those images that you're seeing are test images that Kiera and I tested together as we looked at her model. So she was really interested in hair, and she wanted to build a model that recognized hair that was familiar to her. So this is really aligned towards Black girl hair. We have locks, we have buzz down colored, which I had to look up. It's colored wigs. We have an afro, we have braids, and we have finger waves. So these were her imagination, what she wanted to do, what she wanted to pursue. And we picked different testing models. It works really well. These are images that we just picked randomly from the internet that were not in her training set. So for the most part, it technically functioned well. She trained the models to be able to recognize these hairstyles. And she was, my model actually worked. And then she said if it detected locks, the robot would spin around and do a happy dance. So every time the model detected different types of hairstyles, it was a positive reaction, right? Celebrating these hairstyles that were important to her. When I asked her why she made it, she said, because I love my hair. I think Black girls could use it now. I just got to improve it so that all girls can use it, so everyone's included. And then she also tested it on girls in the classroom. So it worked really well 2 out of the 3 times. So there was one girl, Janae, recognized her braids. There was one girl, Sierra, recognized her locks. It misclassified Mia's natural hair that was tied back. And Mia said, you need to add natural hair. And Kira said, yes, natural hair in a ponytail. Got it. And she wrote that down and she wants to refine her model. So they're testing the model in real time, trying to refine it in ways that are important to them, right? Kira also told me she wanted to improve her model and robot with deep learning. She didn't say deep learning, but that's what she meant. She wanted it to generate hairstyle recommendations based on hair texture. And she imagined users inputting their hair type and the system generating styles and tracking the hairstyle change over time. And this was, again, really important to her. She was very interested in it. We don't have the technology right now to have her do that, but she's thinking, she's imagining. So the key learning findings from this study is that these children connected technical knowledge about machine learning model functionality, algorithm bias, and we saw a deeper sociopolitical understanding of the world being connected with the technical. Deeper connections with race and anti-Blackness in tech. And again, this has to do with that space that we were in, and we had a homogeneous population of all Black girls. And then children reimagined and build machine learning robotic applications for social justice. Now, last time I said sort of. This time I'm framing it different. It's in different ways than I imagined. So I had an image of what building these robots for social justice would be from the literature, from myself. And so we saw them really deeply engaging with bias and anti-Black technologies and reimagining them in the discussions. And their final projects tend to center around personal interests, hairstyles, dancing, books, and food. I showed you one example, rather than overt social justice themes. This is okay. This is actually a really important finding, I think. This idea, when you're working with children in these socio-political technology spaces, the anger and joy can coexist together in these spaces. So because we gave them agency, the girls choose when and how to exercise their sociocritical lens, right? When do I feel like I can engage in this debate? When can I feel angry? When can I react? And when do I just want to resist in a different way? So this is what I'm calling socio-technical Black joy. So Black joy comes from Black scholarship, from Cruz and other Black scholars. They've talked about Black joy in STEM and other areas as a form of resistance against white dominant culture. Just the ability to be free and express joy in the face of oppression. This is a form of pursuing social justice. So developing AI tools that celebrate their identities, that was playful, those serve as acts of resistance for these children. And so this second study really helped clarify that when children are developing these sociocritical AI literacies, maybe adults, I haven't tested it yet, but with these children, both pain and joy must coexist, and children must have the agency to exercise both and to choose when they want to exercise this newly developed critical consciousness in terms of the socio-technical joy. So now this framework is coming together for me. So now, what does it mean? What's happening in this tinkering feedback loop, right? There's questions, there's posing and answering of questions. So here are the actual practices that we're seeing. Children are posing and answering questions about who designs technologies, for what purposes, who benefits and who is harmed, and what are the histories embedded in the data being used. So those are the fundamental questions. The critiquing and reimagining existing technologies, what's happening there is they're using their technical knowledge to ground their social critique and vice versa. So they're using their social understandings, right, to better understand how AI functions. Those things are linked. And they're doing it for social good or justice purposes. But we're reframing how we're thinking about and widening how we're thinking about social justice and social good. So when they're rebuilding, when they have the opportunity to build, negotiate, and appropriate these technologies, children can focus on bringing joy to their and others' lives, particularly those who are marginalized, and to imagine and play with AI in ways that matter to them that aren't always welcomed or visible or celebrated, as we saw with Kira's. So sociocritical AI literacies are not only about critique, they also require nurturing spaces where children can freely express emotion and choose resistance through activism, reimagination, or joyful creation. So joy itself can be a radical act within the context of educational technology, particularly those historically marginalized by its systems. And so this work, I will mention this really briefly. I didn't really have time to talk about this, but this work is now being tested in a broader context in a game-based learning environment. So one of the things we're working on now is this, a lot of this work has inspired the development of this game called Spot, Solving Problems of Tomorrow. And I won't talk too much about it, but we're working with teachers at Metro Nashville to implement some of these ideas in a much more cohesive, narrative-filled, game-like environment. And again, didn't talk about my design work, but through design, participatory design with children, this is what they wanted. And they helped create a lot of this narrative. So children travel to the future, they role play as agents. This brings me back to my days when I was here building games as a grad student. I think I've come full circle. But one of the key things for this is that cohesive narrative that children wanted, but also being able to collect this data on the back end is really important because in that sort of wild environment, we weren't able to collect a lot of the data that we wanted. So this is a hybrid physical and digital role-playing game. It's still the same activities, but it's embedded in this game. We built our own machine learning image classification model that's much more user-friendly for children, much more scaffolded. It's built off a Google Teachable machine, but specifically designed for these purposes, which works much better for us. We were really inspired by, maybe I'll date myself by saying this, but like Tinder apps or apps where you swipe right, swipe left. So children can basically swipe right and swipe left on these images as they're negotiating with the machine. And so, you know, I didn't really talk about that too much, but I'm happy to talk about that more, but that's the next step for some of this work is scaling up these ideas. So I like to do sort of both of this work, scaling up to reach many children in the Metro Nashville School District and beyond, hopefully, and then also continue to do these sort of small level deep analyses with small groups of children. All right, so why does this work even matter, if you remember? So without developing these sociocritical AI literacies, I argue that children are going to continue in these harmful conceptions and productions of technology that we're seeing now. Now, I just feel like this is more than ever really important to develop this critical lens, not just towards technologies, but society more broadly, but AI can be the avenue for children to start engaging with these ideas. I hope I've shown young children have the capability to engage in these deep socio-political discussions around technologies. Adults just need to design for critiquing, tinkering, and reimagining, and thinking about that tinkering feedback loop when it comes to AI technologies. And we need to cultivate this thinking in children. And then who knows how far their imagination can go. Thank you. And I think we have about 10 minutes for questions or so. No, less than that. Sorry, talked a lot. I'm happy to answer your questions about the study, about the game, about anything, big ideas, or I'm happy to take feedback as well. I'm a little vulnerable. I'm sharing this brand new, and I haven't shared this with anyone. It's an exclusive. Yeah. Sure.
One question I have is the STEM fields and areas like computer science have not traditionally been a place where these conversations have happened. But places like classes in like humanities and sciences are. And as you start to move, you showed us like after school kind of things when you're working in schools.
Yes.
Just curious, like which sort of teachers do you reach out
Yeah.
to? Which content areas do you think are likely to be most receptive and most effective in doing this, and, you know, how are you sort of thinking about that?
That's a great question. So I didn't talk about like my other strand of research, which has to do a lot with building equitable research practice partnerships with teachers and co-design with children. And so I have been working from a separate project that I've learned a lot with elementary school teachers. And similar thing, it's like critical data science. But I'm working with 4th and 5th grade teachers in elementary schools, and elementary school teachers, at least the way they're set up in the schools that we're at, they tend to be general education. So they have to teach everything, which is overwhelming, but they teach everything. One of the things that's happening top down is they're getting pressure to teach more computational thinking in K through 8 and are just scrambling, looking for opportunities to do this. And so somebody like me who says, hey, I have this prepackaged set of activities and we'd like to, you know, train you and see what your how you think this can be integrated. Now that part is really important, in the equitable research practice partnership part is, what do the teachers need? What sort of expertise are they bringing to the table, which is their teaching practice. They know how classrooms work. They know their children. They know the culture. They know the community culture. And so a lot of the sessions with the teachers are about negotiating sort of how can we take what we've developed and integrate it into the culture of your classroom in a way that I'm not compromising what I think is important based on the research that I know, and you're not compromising what you think is important based on your teaching practices and your children. And so a lot of times that requires standards, and they have to teach ELA and they have to teach math standards. And so we talk about how we can integrate some of those standards into what we're doing. And then we also think of it as a cultural experience. So some of the characters that you saw just really briefly in the game, for example, like Captain Storm, we have stickers. And so, this becomes sort of like something that's alive for the teachers, and they can put those images on other activities that they're doing in the classroom. So it becomes sort of this collective immersive thing. But those are sort of the different avenues that we've pursued that seem to work when we're working with teachers.
And a question for you. Gary was sitting here, and Jeremy, and I wonder if they have a related one. When I hear you, when I looked at the ENA graph, like a ways in, 2/3 of the way in, where they were able to do the critique and reimagination type test, I realized you actually have evidence to support the current critique in the policy environment, and the current critique in the policy environment of higher ed and of K-12, which is part of the infrastructure that is the war on DEI, is that when we expose children, this is not my belief, I'm sharing what the policy argument is, when we expose children to critical ways of seeing the world, they learn those critical ways. And we don't want them to, is what some in the policy environment think. You actually have data that supports that, because when they were doing certain kinds of tests, they did not make the next step to the critical reimagining. But when you provide them a learning opportunity to critically reimagine, now there's lots of selection bias, like you talked about, in the groups of humans that are doing that work. My hunch is that the pedagogy, the exposure, also would do it with other children as well. That actually supports the argument in the policy environment that it matters a lot what kinds of learning tasks children have, and I would argue adults have also in their higher ed classrooms. So my question is a question about values. Fundamentally, the opportunity to engage in this curriculum is about whose values are we putting in front of children. So I would just, and that's a philosophical question.
Yeah.
It's like whose values get to win, but it relates to how do we deal with bias. One person's bias in AI is not another person's bias in AI. It is just the reflection of the world, which I've heard said to me again and again when I have these conversations. So I'm just super curious how you think about this connection to the values that is implicitly underneath all of this kind of work, but our work as well.
Yeah, that's a lot of a question.
Yeah.
Education policy is fundamentally about values, right? It's about values and it's about power. And so the people who are in positions of power get to determine what those values are. And historically, right, it's been like white, able-bodied, we know this, right? Men, yes, as Mia pointed out. So we know that historically, and so those are the people in positions of power. And so critical theory is is a lot. I mean, to be able to really dig into those nuances of critical theory takes a long time. So what I would say is that getting people to sort of see and realize, right, that making those implicit biases, again, as one of the kids was talking about, more explicit for people. I guess my argument is that AI can do that, like you said, because we're sort of, if we open up kind of the box of AI and look at the training data and look at the outputs and look at the inputs and sort of understand why that's happening, I think that's an avenue for getting people to think more critically about the world itself. So this goes beyond just the technology and beyond AI. But yeah, it's fundamentally values. So this is the way that I and other scholars see the world, right? And we think it's important for children to understand the hegemonic structures, the systemic oppression that we live in, and to be able to think about what it means from a human dignity point of view, right? What does it mean to treat all people with dignity? What does it mean to understand where all people are coming from? And so, I mean, I don't know if this answers your question, but it's all about values, you know, and it's about different ideologies and helping people, I think, to see the different points of view. It's just, I'm pushing this agenda because this agenda isn't visible, right, in the schools. It's not visible to a lot of people. The other stuff has been visible. So now this is an opportunity to sort of push this. I'm not saying we shouldn't teach about anything else or any other things, but this has been sort of, this critical lens has been pushed down and has been argued, why are we even teaching young children about this? And there's a lot of research that talks more about why we should actually be teaching children about this critical lens, and that children start to recognize these things about our societies very early on at age 5.
I think we're out of time.
Yes.
So we'll just thank Cole for.
Thank you.
Yeah.
Great, that's great.
Oh, thank you so much. And